Hey everybody, this is Larry. This is day 19 of the March Leetcode Daily Challenge. Oh man, I need a haircut. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, keys and rooms. Yeah, I do these live, so if it's a little bit slow, just feel free to fast forward. I hope everyone's having a great day, great evening, wherever you are. And let's see. Okay, there are n rooms and you're at 0. There's some numbers, okay. Each room has keys. Okay. Return true if you can enter every room. Okay. So it seems like, I mean, this is a connectivity problem. It's a graph problem. It's a graph problem because these keys are going to be edges, right? From room A to room B, kind of not directly, but having a key allows you to get to that room. And so essentially you have a graph from room A to room B, and you start with room 0 or 1. Yeah, you start with room 0, and then you try to see if you connect to every graph or every room. So of course this is a connectivity problem, and there are a couple of it's connectivity, or you're trying to see if the graph is fully connected, and usually you can do this in a number of ways. You could do it with depth first search, you could do it with breadth first search, you can do it with union find, as usual connectivity problem. This is a very basic problem in terms of interviewing. It comes up a lot from what I understand, so definitely practice variations of this. Okay. Which way do I want to solve it this time? And also, as I said, because of linear, what did I say? Oh yeah, because this is a connectivity problem, the solutions are all roughly linear, or depending on how you want to explain union find, but they're all roughly linear, and as a result, I didn't have to look at I didn't have to look at constraint as a result, because I didn't, it's roughly linear. It's going to usually be fast enough, so I didn't have to look at it, because it's, otherwise it's just implementation maybe. But yeah, cool. I'm just trying to figure out what I should do with breadth first search, depth first search, or union find. Today I'm going to do it with breadth first search. I'll tell you why for a second. It doesn't actually, I think this is just a lot of preference, but the reason why I like doing a breadth first search is that it's linear. It's V plus Y, which is vertex plus edges, which kind of, number of edges is at most 3,000, but also, what's the other thing I was going to say? Oh yeah, because depth first search, which is great, which is good enough, in theory, you may run into stack limit, stack overflow, stack limit reached depending on the recursive depth, which in this case, or in general, should be O of V, but which for 1,000 is probably okay. But these are things that I would talk about in an interview. And union find, you can definitely do union find. It's not a big deal. And maybe if you're struggling union find, it's a good practice for union find. I'm not going to do union find today. I'm just going to do a breadth first search. So for the rest of this, I think this is going to be way, I wouldn't say template. I write similar things every time, but I don't, memorize it. I just basically go through a couple of principles. So let's do them. Let's go through them together. Cool. Yeah. So first, I define a queue, or maybe one of the first things I do. And a deck is just a double-ended queue. So yeah, like you could pop from the front end, the end. It's, at least in Python, it's the standard way of doing things, I think. Do I need to convert this from anything? No, I guess this is already in a good way. So yeah, so basically now we want to, the way that I want to do it is in queue of a room, say, and that just means yeah, append room. We don't need anything about distance or anything, and yeah, and then maybe in this case we also say scene of whoops, and we have n is equal to the length of rooms, and we have a scene array of so that we don't go to the same room more than once. Yeah. And then now we just do while we have a queue item, and I know that in Python you'll see this win maybe another way, but I'd like to make it explicit, even though it should be the same anyway, right? Though I guess greater than is a different assembly instruction, but it's fine. Yeah. So room is equal to queue.pop left, and then now we're giving a room. Now we look for the keys, right? For key in room sub room, which is now that means that we're able to reach that room now. So then we go, okay, if not seen, if we haven't been to this new room, then let's unqueue it. This is an awkward phrase, I guess. Next one, maybe that's a little bit better. And that's pretty much it. And then at the very end, we want to make sure that this array is all seen, meaning that we've been to all the rooms, and that's the way that I write it. Or you could add, write a for loop. It's essentially the same thing. Python and some magical stuff. Yeah, let's put in the examples. And hopefully they're good. Oh no. So it's false. Why did I have false? Dong dong dong. Let's put it out real quick. Huh. Oh, silly. I actually meant to do this, but I forgot, obviously. We have to enqueue the first room that we've been in. What a silly mistake. Whoops. I was thinking about writing it, but sometimes, actually, during a contest, I think I'm a little bit better about it, but I still do this. But because I spend a lot of time talking about the solution when, on the live explanation, that sometimes I just forget because I'm talking about it too much. I think about what to say instead of thinking about what to implement. I miss things like this. That's my excuse. I'm sticking to it. But yeah, this is accepted, so that's great. So what's the complexity, right? Well, each room which is n, it's going to be in queue once. So this loop will execute all of n times, and let's use n to v, where v is the notation is vertex, right? V is equal to vertexes, which is equal to rooms in this case. And then here you can say that usually you have this expression of v plus y, because y is equal to edges, and in this case it's equal to total number of keys, right? I mean, it's tempting to say that this is v square, and in the worst case it is, because each room can have, well, maybe even multiple keys. I actually didn't look, but each room can have v number of keys to other rooms, so it could be v squared in the worst case. But the thing to notice is that yeah, so it's gonna be v squared, but you can actually do better, because this for loop only looks up this for loop only loops the number of times with the number of keys you have, right? You can imagine another if they give you the input in a different way, in an adjacency matrix, for example, instead of an adjacency list, then it's going to be v squared, because you have to check every room to see whether it is true that it that has a key. But in this case, because of that, it's going to be v plus y. And why is it plus y? Because y is equal to the number. Like if you sum over all these for loops, then you're gonna sum to y, right? For example, and this is just a really weird example, but okay, let's say this example too, right? Well, that means that this node, node 0 is going to have 2 keys, node 1 is going to have 3 keys, this is going to have 1 key and 1 key, right? Oops. So that means that even though v squared would be, I don't know, 4 square, technically this will, this for loop only iterate 2 plus 3 plus 1 plus 1 times, which is equal to 7, I guess. And as a result, it doesn't go through every room for every room. So yeah, so this is the O of v plus e. And of course, as a result, that is actually linear time because that is the size of the input. So yeah, the size of the input is v plus e, or technically it's just e. Maybe it's v plus e because you can have empty arrays, but yeah, either way, v plus e. So this is linear in the size of the input in terms of time, and in terms of space, it's going to be O of v, because yeah, we have these two things. As I said, the queue will have at most v elements, and scene array has, well, n elements or v elements. So yeah, that's all I have with this problem. This is a basic connectivity problem, so definitely if you have any questions, let me know, but definitely you have to practice this, you have to know this. This is pretty basic things that if you have trouble with, and you're going to have trouble with a lot more, because this is just a basic part of it that you need to build on top of this in terms of like getting to like shortest path and stuff like that, which is something that is definitely considered something that you should know for interviews, and well, definitely for competitive. Cool. That's all I have for today. Let me know what you think. Hit the like button, to subscribe, and join me in Discord. I hope you have a great day, great night. Stay good, stay healthy, to good mental health, and I'll see y'all later. Bye bye.